So what we're doing today is we are continuing our review in Chapter 8 over exponents. So we have focused on kind of at the very beginning, Part 1 that I've already posted on the multiplication properties of exponents, zero exponent properties, and also negative exponent properties. So that has kind of been our focus. So let's continue with our review. In this next one, they tell you that you have that you already have a sequence. So here's your sequence. Now with that sequence, one of the things that I'm looking for is how can I go through and find the next three terms. So in other words, I got to figure out how these numbers are changing so I can continue the pattern. So if I were to look, I want to think about how things are changing to go from one to the other. So 3 times 9 is 3. Then 9 times 3 is 27, and 27 times 3 is 81. So I think I found now that our common ratio is 3, which means I have to multiply over and over again by 3 to create the next number and the next number and the next number. So if I went through here, my last number is 81 in that sequence. If I multiplied by 3, so 81 times 3 is going to give me 243. Then I take that number and multiply it by 3, and I will get 729. And then 729 times 3 is 2187. Now my job was to find the next three terms. And if I look at what I've already created here, these would be the next three terms. So if I was to look up at our problem, that means our answer would be B. Now, if you're talking about good test-taking skills, if I were to look at problem 11 and I would see that A and B are exactly the same except for the fact that they're positive and negative versions of it, that might give you a hint that that's obviously some numbers that we want to look at. You can also look around this problem and see 81, which was the last number to begin with in this sequence up here, is used again. That's probably a big hint that that's probably not the right thing. And there's no way I could get to 87 from 81 just by multiplying. So I know this one's out. So you're really just down to choices of A and B. So use those test-taking skills to kind of narrow down your answers. Okay, let's take a look at the next one. This one says determine whether the sequence is arithmetic or geometric. Remember, arithmetic is adding and geometric is multiplying. So if I'm looking at these numbers and I'm trying to find the pattern that goes on here, I already know they're not going up by the same numbers every time. So there's no way this could be arithmetic. So it's kind of making me think maybe geometric. The other thing is, if this goes back and forth between positive and negative, the only way that could really happen is if you're multiplying by a negative number. That's the only way that you would be able to get this kind of positive, negative kind of pattern going on. So if I look, I'm at negative 2 and I go to 10. That's a multiple of 5, even if I'm not looking at the negative. So it's kind of easy to see kind of this negative 5 piece. So this would be my common ratio, which means it would have to be geometric since it's multiplied by over and over again to get the next answer. Okay, now, next problem is about evaluate. So remember, we said earlier that when you see this word evaluate, that you're going to have to think about plugging your values in. So if I'm plugging stuff in, they tell me actually what they want me to plug in this equation at negative 3. So that means that I'm going to take my original equation and I'm going to take this negative 3 and I'm going to plug it in here. So y equals 15 times 3 to the negative third. Now, as soon as I go through and see that negative exponent, I'm going to put it over 1. And the thing that's unhappy where it's at really is this thing right here. That really wants to go to the bottom. So when it goes to the bottom, the exponent becomes a positive 3. And the 15 is going to stay where it is. Absolutely stays put. No negative exponent with that. And then this 3 to the third that's on the bottom is going to become 27. So I have this 15 over 27. Now, one thing that I really want to consider on this one is if I can possibly reduce. Now, this may be done as far as, you know, being able to multiply out stuff and do that kind of stuff. But I could also see in this that a 3 could go into both of these to reduce. So 15 divided by 3 is 5. 27 divided by 3 is 9. So this 5 over 9 is really my final answer. So that means C is my answer on 13. Okay, next problem. This is another one of those things where they want us to take a value and plug it in. So I'm going to take my f of x, and instead of having x, I'm going to put negative 5 in all the spots where x is at. Now this is one where I have a negative exponent, so that means that I'm going to have to put it over 1. And this value is going to have to go to the bottom to get rid of that negative exponent. Now, in this problem, 3 to the 5th isn't completely done. Anything you can simplify, they're expecting you to. So if I did 3 to the 5th, that would be 243. I'm going to put 1 on the top. That keeps everything in the bottom. So this is going to be my final answer, which means that my answer is C. Ooh, we're getting towards the end here, guys. Okay, next one. Now this is one of those story problems that we did early on as part of 8.7 and 8.8. So this says, suppose that the population of a town is 2,700 and is growing at 4% a year. They want to have an equation to model, and they want the population after 12 years. So we have 2 jobs to do. First of all, here's my general equation. They tell me in this that 2,700 is going to be my beginning population. So that part's going to go in for the A. Now to figure out this B value, first of all, it tells us it's growing by 4% a month or a year. So I'm going to take my 100 and add my 4 to it. My now new percent is 104%. But remember, we said in these kind of problems that you can't leave them in percent form to be able to put them in the actual equation. So I have to move the decimal 2 spots, which means it's going to be 1.04. And that's what's going to go in for B. So 1.04. And remember, we said a lot of times as soon as people see that negative, you'll start to see them using the parentheses a whole lot more. And then x is going to go in there. That's our model equation. So this is actually what they're talking about for A. So if I were to look up here, this isn't right. The 2,700's in the wrong spot, at the very least. The next one, this is just 4, and actually so is D. So I'm knowing all along on 15 that my answer is probably going to be C, because I can see the beginning part. This matches the equation I just made for this. Now we just need to check our values. So if they want us to check it in 12 years, we're actually on B going to have to use x equals 12. So that means my y is still there, 2,700. 1.04 is going to be raised to the 12th. So 2,700 times 1.04 raised to the 12th, and you end up with 4,322.78699. So in this kind of a problem, now we do need to remember in a problem like this, if we're talking about population, we can't leave our answer this way. We'd have to round it to the nearest whole number, which would mean that we'd have to round to here, and we have to look at the number that comes after it. The number that comes after the decimal is 5 or bigger. So that means that because this number here is going to be rounded up, we have to be to our nearest whole person, be 4,323, which does match our answer up here for C.